In this lesson, I will be talking about the intersections of lines and planes. When I'm talking about lines and planes, there's usually three different interactions that are involved. The first is in which we have a line that intersects with a plane, like so. The second scenario is where we have a line coincident with a plane, which basically means that both the line and the plane rest on the same axes. And the third situation is when we have a line that is parallel to the plane. So in all three of these situations, the first situation is where there's one unique point. This is because the line and the plane only intersect at a specific point, point P. In the second situation where the line rests on the plane, there's this infinite number of solutions because it's any point on the line. And when we look at the third example shows that there's no intersections between these between this line. And so the question is, why is this important? So if we were to draw this out one more time, and we had a plane rested on the x-axis. Let's just say this is the plane, and just say this is kind of like the ground. So we'll leave this the ground. And we had another plane, a line coming towards the ground. So let's just say something like this at this point. What's useful about this is that we can determine the point in which the line and the ground intersect, and we can symbolize this line to be in a plane. Okay, so if we kind of take it into consideration the trajectory, or the path rather, a plane takes to the ground, this can be useful information when determining the velocity and the angle in which the plane lands relative to the ground, because it can help ensure the safety of many passengers.
All right, for the first question, determine if the line and the point intersect. If so, determine the solution. So we have been given a scalar value, which is pi1, and it is 9x plus 13y minus 2z equals 29. We also have a parametric equation, and as you can see, this is L1. This is our parametric equation. So we have x equals 5 plus 2t. We have y equals negative 5 minus 5t. And we also have z equals 2 plus 3t. So you guys probably realize that we have different variables here, and x, y, z are three different variables. And you guys probably also realize that those three variables in the parametric equation is also in the scalar equation x, y, z. That is because the first step to this problem is to actually substitute those values in. So to start off, so we have 9, so we could write 9 again. And then our x value is going to be 5 plus 2t. Now same thing goes for the y, so we're going to have plus 13, and we can have minus 5 minus 5t. All we're doing is just substituting the values. And then we have a minus 2, and our z value is going to be 2 plus 3t, which is all equal to 29. So far, so good. Now, the reason why we're substituting, now we're trying to find the value of t. Now, the next step would be to obviously multiply and distribute the numbers. So we have 9 times 5, which is going to give us 45 plus 18t. Now we have 13 times negative 5 is going to give us negative 65 minus 65t. We have minus 2 times 2 is going to give us minus 4 minus 6t, which is all going to equal to 29. Now the next step is obviously what I like to do, and makes it easier, is to put all the like terms together by putting all like terms together, you could like easily see and see what you could add up together. So we could say 18t minus 65t minus 6t equals to 29. And now we're going to take the minus 4 to the side, it's going to give us plus 4. We're going to take the minus 65 to the side, it's going to give us positive 65. Taking 45 to this is going to give us minus 45. Now, we know 18 minus 65t minus 6t is going to give us minus 53t. 29 plus 4 plus 65 and minus 45 will give us 53. Now, the next step would be to obviously divide. So we're going to say t equals 53 divided by negative 53. T equals negative 1. That is our value for t. So t has a value. So as you guys can see, there's actually a real number of t. T actually has a value. So the line and the plane will intersect at a single point. So if this was our plane, there will be one point where the line and the plane would intersect. So, and to find the exact point of intersection, we will need to place the value of t back into the parametric equation. So let's just do it right here. So we'd go x equals 5 plus 2, and our t value is negative 1. Now, 2 times negative 1 is going to give us negative 2. 5 minus 2 is going to give us a positive 3. Let's do it for y now. Minus 5, and negative 1. Minus 5 times negative 1 is going to give us positive 1. Minus 5, positive 5 is going to give us 0. And for z, same thing. For z, let's put this in the camera right here. For z, we're going to have 2 plus 3, negative 1. 2, negative 3, minus 3. And we're going to say minus 1. Now, therefore, our point of intersection is going to be at 3, 0, negative 1. Time to move on to question number 2. So for question number 2, it's going to be very similar to question number 1. So the question number 2 states, determine if the line and the plane intersect. If so, determine the solution. We also have another scalar, another pi value, which is going to be 4x minus y plus 11z equals negative 1. Same thing as the first question. But now our parametric equation is a little different. It's not the same as we had before, the 3 equations. This time we gotta separate our variable. We gotta isolate our x, we gotta isolate our y, and isolate our z. So to do this, we're gonna obviously write L3 because that's the value. We're gonna add the little cool brackets. And now we're gonna take so for x is the first variable. So we're gonna go to the other side, look at the first variable, which is negative 2. We're also gonna look at the first variable, which is 3. But remember, this t is multiplying to all 3 of these values. So it will be 3t, for instance. So x would equal to negative 2 plus 3t. Now, if you guys want to try attempting this question, make sure to pause the video while we're going, because I don't want to waste time. So now we have y. Try attempting y. Pause the video. So for y, same thing. Y is going to be the second variable, which is 4. And then we know 1 times t is going to be t, so it's going to be plus t. And for z, it's going to be z and equals for 1. And we know t times negative 1 is going to be minus t. Now we're back into a similar case just as question number 1. So obviously we're gonna take this and substitute into our main scalar equation. So we're gonna have 4. Our x value is gonna be negative 2 plus 3t. We're gonna have minus 4 plus t. We're gonna have plus 11, 1 minus t, which is equal to negative 1. Now the next step is to obviously distribute it. So 4 times 2 is negative 8 plus 12t. We have a negative 1 here. So negative 1 times 4 is negative 4 minus t. Then we have a plus 11 and a 1. So it's going to be plus 11. And it's going to be minus 11t equals to negative 1. Now the next step will be obviously what I did before. Put the like terms together. So we're going to have 12t minus 11t equals to negative 1. We take negative to the side, it's going to be positive 8. We take positive 11 to the side, it's going to be negative 11. We take negative 4 to the side, it's going to become positive 4. Now 12t minus t is going to give us 11t. 11t minus 11t is going to give us 0t. Let's make that t a little better. And then we have 8 plus 4 is 12. 12 minus 1 is going to give us 11. 11 minus 11 is going to give us 0. So t, you cannot do 0 over 0 because that's an incorrect value. So there's no value of t. So this means that this equation is true for all values of t. And whenever you get this case, it refers to that the line is a solution by being completely on the plane. So for instance, if this was our plane, the line will be completely on the plane. Now, so whenever you get a value of 0t equals 0, just know that t could be any real number. Time to move on to question number 3. Alright, time to move on to our third question. Probably might be one of the trickiest questions in this whole chapter of 8.5. The question is, determine the distance between each point and the given plane. So we are given a point, which is point P, and point P is exactly at 3, negative 4, and 6. And we're also given another scalar value, which is 2x plus 3y minus 4z equals 8. This could be also written as 2x plus 3y minus 4z minus 8 equals 0. All I did was take the 8 to the other side and then minus 0. Now, whenever you're giving a question where it's to determine the distance, so when you try to determine the distance, you're trying to determine the minimum distance. You're not going to try taking the longest route. You're going to try finding the shortest route possible. The formula for this is going to be d equals, we're going to have the magnitude of normal, dot product, magnitude of PQ, and we got to make sure these are absolute value, over, we're going to have the magnitude of normal again, and we're going to have that absolute value. The reason of absolute value is to make sure the number stays a positive value. So now, as we can see, we need to find we need to find our normal. We need to find our distance. We are given our point P, but we don't have point Q. So let's start by finding our normal. This is our scalar equation. It's really easy to find a normal because normal is going to be equal to A, B, and C. Or it could be X, Y, Z, or it could be I, J, K, whatever variable works with you, right? So as you can see, our A value is going to be 2, our B value is going to be 3, and our C value is going to be negative 4. That's going to be your end point. Now to solve for point Q, we need to try finding out a certain value. So we have to make two of these variables equal to 0 to solve for one of this. So let's just say let's try solving for the value of z. So that means we got to make our x 0 plus 3, y is going to be 0 minus 4z equals 8. Now we know 2 times 0 is going to be 0, 3 times 0 is going to be 0, 0 plus 0 is 0. So it's going to be left with negative 4z equals 8. Now we can isolate for z, which is going to be 8 divided by negative 4, z equals negative 2. Now we know negative 2. So for Q, when x is 0, y is 0, z is negative 2. That could be our Q point. Now to solve for PQ, we would need to multiply them or like subtract them. We need to do y2 minus y1 for all three values. So we're going to have 3, negative 4, 6, and then we have 0, 0, and negative 2. So what is 0 minus 3, which is going to give us a negative 3? 0 minus 4 is going to give us a positive 4. And negative 2 minus 6 will give us negative 8. Now that's our point PQ value. Now we know our normal, we know our PQ. Let's put it into the equation to solve for distance. So D equals, our N is going to be 2, 3, negative 4. Dot product of negative 3, 4, and negative 8 divided by the square root of 2 squared plus 3 squared. And it's absolute value, so it's yes, a negative 4. We can just convert that into a positive 4 squared. It doesn't matter. Now we have d equal. Now we do dot product of the numerator. So 2 times negative 3 is going to give us negative 6. 4 times 3 is going to give us plus 12. And negative 4 times negative is going to give us plus 32. Over, let's just put this a little down so you guys get a better view. So 2 squared is going to be 4 plus 9 plus 16. Then we could also say 32 plus 12 is going to give us 44 minus 6 will give us 38 over, if you add all these up, you'll get square root of 29. You could also write this fraction, if you convert it by using a calculator, you'll get 7.05 units. And that's going to be your answer. So therefore, the distance between each point and the given plane is going to be 7.05 units. Now my boy Jagdeep is going to take it on from here.
In this example, we will be determining if a line intersects with a plane. So in our line equation is given by r vector equals 1, 0, 1 plus t bracket -2, 1, -4. And our pi 1, it's what it's referred to, or plane 1 rather, is 4x minus 2z equals 11. And we look at the direction vectors of these, that's expressed as m vector, is -2, 1, and -4, as shown here, which is the direction vector for the line. And for the direction vector for the plane is set as 4, 0, and -2. And so what we first do to determine if the line intersects with the plane is set m vector dot n vector equal to 0. And what that means is that when m vector and n vector equals 0, both the vectors are orthogonal to one another. So if we when we do x1 or m1 n1 times n2 m2 times n3 plus m3, we get -2, 4, right? Because we have -2 here and 4 here, plus 1, 0, plus 4, -2. Sorry, -4, which equals 0. So if you see here, -2 and times 4 will give you -8. This will give you 0, and this will give you +8, which equals 0. Both -8 and +8 gets cancelled, so 0 equals 0. And what this means is that both the m vector, see if I had a plane here, and let's just say this was m vector, and this was n vector. This equation basically states that both m and n vector will be orthogonal to one another, and what that basically means is that they will be perpendicular to one another. And so what we do next is we see, so now we know that the plane is going to be in the same direction as the line. So what we check now is we make the left side, see if the left side equals the right side, and if this holds true, then that will mean that the line and the plane are coincident to one another. But if it's not true, then that means that they are parallel to one another. So left side equals 4, 1 minus 2, 1, and the left side would equal 4 minus 2, and it would equal 2. So from the left side getting 2, we know that the right side equals 11. And the equation, sorry, I subbed it into was this equation. right here. So I subbed in the x value as well as the y value, and I got this. So now we know that left side does not equal right side. We know that the line and plane are going to be parallel to one another, and that means that no lines, the line and plane do not intersect. So just as a visual representation, if we have a coordinate system laid out like this, if we have a plane like this, if we have a plane like this, we will be getting a line that looks something like this, which is parallel to the plane. Now let's do an application problem. In this question, it states Mary is walking to school with Robert. The direction in which Mary is walking is defined by the equation x plus y minus z equals 6. Meanwhile, Robert points a laser where Mary is looking at the equation expressed by this. Determine the point in which Robert points his laser with respect to Mary. So first thing we will do is separate put this equation in parametric equation. So we're gonna have x equals 8 plus 3t. We're going to have y equals -1 because t is 0 at the y component, and z equals 4 minus t. Now we have our parametric equation, and what we'll do now is substitute these values into this equation. So I'll just bring this down here, or actually I'll write this here. So if when we have x, or I'll write the equation first on top. 6. So x would sub in for that, y would sub in for this, and z would sub in there. So we'll get 8 plus 3t minus 1 minus bracket 4 minus t, comma 6. Now, when you expand this, you'll get something that looks like 4t equals 3. So therefore t equals 3 over 4. So now we know the t value. What we will do now is substitute the t value into this parametric equation to determine the point in which Robert is pointing the laser at Mary. So for our x component, we'll have 8 plus 3 over 4, which will give you 41 over 4. We have y equals -1. There's no t value, so it'll just be -1. And finally, z equals 4 minus 3 over 4, which will give you 13 over 4. So therefore, the point you get is P 41 over 4, -1, comma 13 over 4. So this point is the point where Robert's laser intersects with this plane, you could call it, which is the direction in which Mary is looking.